Okay, so now going in the other direction, let's say we wanted to write a single logarithm in terms of an expression involving simpler logarithms like log A and log B. Well, we use the same properties. Here we have the log of a product, okay? The product of a cubed times b to the minus 5, so this is going to be the log of a to the third plus the log of b to the minus 5. And then you can see we can take this 3 out front here and this negative 5 out here, and so this will be 3 log a plus negative 5 log b. Okay. All right, so you can leave it like this, or you could say this is the same as 3 log a minus 5 log b. Over here for part B, first and foremost, we're taking the log of a fifth root of something, so this is the natural log of ab squared, this whole thing raised to the 1/5. And the way you can do this, you could pull this 1/5 out, or you could just simplify this product within the log. This is a to the 1/5 times b to the 2/5, so maybe we can do that, or maybe actually we'll just pull the 1/5 out here. And then we can say, okay, now this is a product, so this will be 1/5 times the log of a plus the log of b squared. And now this 2 will come out here. And then finally we can write this as 1/5 log a plus 2/5 log b. Okay. Here in part C we have a product again. This is the log of e plus the log of a to the 4th. And the log of e we just said is 1. And then this is going to be 4 log a. Okay. Now, one thing before we go on, you want to be careful as a warning. Okay, the log of a plus b is not equal to the log of a plus the log of b. Okay, we know this is not true because we know that this side is actually equal to the log of a times b. But students make this mistake all the time. They want to distribute the log so much. But log of a plus b, there's no nice way to simplify this because of that addition just really screws us up. But you want to be very, very careful about this. Also, the log of a b, this is not equal to the log of a times the log of b. Okay, so there's 2 very important things to keep in mind. All right, the more properties, and we touched on this before. We said that the exponential functions and logarithmic functions are inverses of each other. Meaning if we plug one into the other, we get what we started with. So we take a raised to the log base a of m, this is m. This follows out just from the definitions because we said the log of m base a, that's the number. If we raise a to it, we get m. Well, we're raising a to it, and so we get m. 2 special cases, when a is equal to e, we get this, and when a equals 10, we get this. And this holds for all positive m. It doesn't hold for all real m because you can't take the log of a negative number, right? So this holds for all positive values of m. We compose them the other way. We get get the log of a to the m base a. What is that? Well, this expression here is the solution to a to the x equals a to the m. Okay, well, we can clearly see that the solution to this, x has to be m, so that's why this is m. Again, the case where a equals e gives us this. The case where a equals 10 gives us this. And this holds for all real numbers because obviously we can take a to the m is defined for all real m, and a to the m is always a positive number. And then finally we have the third property, which is also very important, is says that the logs are 1 to 1. Well, the log function is 1 to 1. That the log of m, if the log of m equals the log of n, as long as it's the same base, we have m equals n. And the reason for that is if log base a of m is equal to log base a of n, then if these two numbers are equal, then these powers are going to be equal. And so this from number 1, this tells us that m equals n. Okay. All right. So this is going to be very useful when solving logarithmic equations in some cases.